I'm now going to show you some techniques for optimizing dummy objects in order to reduce the polygon count of objects that are going to have carbon scatter populations. This scene, what I have right now is just the dirt object from the scene with the structure, where I had a gravel, a set of rocks, as a carbon scatter ecosystem. And what I did was control the distribution with the mask image that I had set up, which was this image, controlling the density. And that made it easier to cut things out, but the geometry itself was causing a very large lag, an extended time to populate the objects onto the white areas of the density. So using this object with such a high polygon count isn't really efficient. If we go ahead and take a look at the polygons, you can see there are quite a few. And the displacement itself is fairly simple for this. Obviously, we can have much more complex objects, but what I want to show you is how we can just use Cinema, generate some different images and some different objects that are going to be better for the population and also better for painting, because there is going to be a bit of a delay when you're painting carbon scatter ecosystems onto higher res geometry. So we're just going to take a look at making things more efficient by optimizing geometry, and also looking at some different ways to control populations using simple objects like planes as a base point. So let's take a look first at some imaging techniques. We can render some materials to affect the ecosystem and not need all the geometry, and we'll be able to effectively populate onto a single polygon equal size, and then just use images that we can load into Carbon Scatter in the function editor to control position onto the surface, and also whether or not the objects will appear on certain slopes or altitudes. So the first render we're going to make, and we're going to create a new material. And this is going to be for altitude. So this is going to be our altitude material. And we're going to keep the object in its present location, which is the same as the main structure scene. So what we can do is define values that are going to rely on basically this 0y axis. So the altitude material, we're going to go to luminance, turn off the specular value. We want to use luminance so that light doesn't affect this. And we're going to add a gradient to the texture. And we're going to set this to 3D linear. Turn off the cycle. And first reset the start and end points to 0. So our starting point is going to be 0 meters on the y, because y is my up and down axis. And just to get an idea where the position is, because I don't have this baked, I'm going to use just another object to line it up. So I'm going to add a plane. And right now the displacement isn't showing in here, so I'm going to switch over to the wireframe mode within the viewport. So 0 is our low point, and this is where we're going to have our population plane is at 0. And then we need an image to take a look at the altitude from 0 up into the top of the object and the top part of the displacement. And the geometry. So we can just move this plane just created up to the top, and then take a look at its position, which is 0.022 meters. So that is going to be our endpoint. And then we can switch over, obviously apply this to that object. We can delete our plane. And then I'm going to add in a camera. And first go into that gradient under the luminance channel and set this to linear, making sure that it's not doing any additional smoothing. We do want a linear amount. We don't want any modifications because we do want a pure altitude. So the camera we're going to select and change over to a top camera. And then we're going to go to the render settings and just set our output to 1024 by 1024. And the best anti-aliasing, just default, should be fine. You can line this up as best you can, or I just prefer to crop it in Photoshop. If you don't have access to an image editing application, there are free ones available providing simple and very advanced editing. Along with the training, you'll find a folder that contains links to a free open source program called the GIMP, and that's going to be basically a Photoshop equivalent. And provides a lot of the same tools that I'm using. So right now I'm just setting up and changing the view so I can see my extent a little bit better. Like I said, I don't really need to worry about being exact about this because I am going to just crop it out. Now, if you don't have any material that is going to the edge, you might want to set up a bit of a composite, and this is going to make it a little easier to set up sort of an alpha. What we can do is add in a compositing tag. So right click on the object, Cinema 4D, Cinema 4D tags compositing, go to the object buffers and enable buffer 1. And then under the multipass for the render settings, we're going to add in object buffer, and that's going to be automatically set to 1. And then we'll go ahead and just add in the RGBA image, which is going to be our surface. Turn on the multipass, and then we can go ahead and render this out. So we can now save this image out with the additional layers, so it is going to need to be a format that is compatible with the built-in buffer in the alpha. So if you take a look at the single pass, this is our object buffer, just within the extent, the terrain, or within the frame, so matching the object. So we can go ahead and save this out. What I like to use in this case would be just a 16-bit TIFF format, including the alpha channel. Don't need any additional layers because it's just the RGBA image that's included with it. So we can go ahead and save that out. Now I'm going to set up another material, and I do want to make sure I'm not moving the camera. This way what I can do is just load in the multiple images, and then when I crop them, I'll just load them all together as different layers within the same document. I can crop them all in one go. Makes it a lot easier. So the next thing we're going to do is create a material for slope. So add new material, slope, and basically set this up for that same setup where we're using luminance. And what we're going to do is set up an effect. Under effects, we're going to use fall off. Go ahead and assign that to the object. And I'm going to set this up to world space. What I'm also going to do is just right click on this dirt object, current state to object, and then hide the original object. Going into the gradient, right click, reset, and then add in new key points. Set it to linear. And we might need to drag in those points kind of far in order to get our slope range, because it is basically an equal amount of slope throughout the edges. There's not a lot of change. I've just expanded this so we can see the gradient a little bit better. Because of the way gamma is set up and just the way we see, it is going to be easier to see the lighter tones. So I'm actually going to reverse this. One thing we could do is just type in a negative value, but we will need to change the way that's set up. So I'm actually just going to switch these points. So we'll do white and then add black to the end, because it is just going to be a lot easier to see the lighter values as they change than the darker values. We can throw in a color too if needed. So as you can see now, we are picking up a lot of detail that didn't really know was there, just because it is a lot easier to see the lighter hues or lighter tones. We can set up a color if you want to assign it that way, or even a mixed amount throughout. And we could clip the range if you want to set it up ahead of time, but this should be good, just this gradient. So we go ahead and render that out. And now we've got something for slope. So those are really just the two materials I think I need. Go ahead and just remove those tags. Now, if we were planning on painting on this surface, we would want a lower res version of this, and Cinema 4D has a really good and quick tool for this, which is basically just the polygon reduction. So what we can do is just add the polygon reduction object, Deformer, and that can be found under Objects, Deformer, Polygon Reduction. I've got a quick access to a lot of the frequently used objects and tags I use a lot, so mine's just right here in the interface. What we're going to do is apply that to the full geometry object. Once we add it, we then click off of it, and it's going to update and create the lower res version. So you can see we have a large reduction of polygons. And this will work better as a painted surface. We could go further. We can really just adjust the reduction strength. Right now it's at 90%. We could bring it up further if this is still too high. It has been reduced quite a bit. But let's go ahead and bring it to 95 and take a look. And it's basically taking it from 720,000 polygons, and that's because it is going to triplicate the polygons, turn them into tris instead of quads, before the reduction. So it's actually going to show twice as many polygons as there originally are. But it's still bringing it down by a very large amount. So once that's set, what we can do is just right-click on the object, current state to object, and then I'm just going to turn that off from the view, turn off the polygon reduction. And then if we take a look at the object, we could do further modifications. Basically, if we go to functions, we can untriangulate this. We can choose to evaluate the angle and create n-gons. Now, depending on the polygon count, higher polygon counts for this are going to take a really long time to calculate. Anything above 250,000 polygons. I've had terrains before where I've done 500,000 to a couple million polygons, and it'll take a good 20 to 30 minutes to calculate a low angle n-gon. I'm going to show you right now with an angle of 2 degrees. It does look like that wasn't high enough. Or low enough, so let's go ahead and set this to 0.5. And I might even need to move it up a little higher. In some cases, it won't be as effective. Let's try 15 degrees. And this object just may not be working well for that. One thing I could do is now pay attention to your Y size to begin with, 0.032 meters. Because what I'm going to do is scale this up to a meter, and then go back to the untriangulate. And maybe I need to use, I think, a higher amount. Set that to 45 degrees. Bring it up to 90, and it looks like that is going to trigger it. So it does look like I need to use a higher amount in this case. And that is going to take a little while to process. It does look like that's just not working right now. Normally does. So we'll bring it back. One thing we can do is just turn off the n-gon creation, untriangulate, turn off that create n-gons. One of the easiest ways is to just turn off the evaluate angle altogether. Click OK, and it's just going to remove all of those triangles, or at least most of them. The ones you'll find on the steeper parts, steeper slopes, are typically going to remain, but this becomes a much more efficient object to populate on. And then you can further reduce the polygon count if needed. I had a reduction of about 95%. You can bring it down further than that. It really just depends on the object you're populating on. In this case, it's a little easier because it's more like a terrain. So we've got a lot more flexibility for the reduction, and it really won't take much. But this does make it a little easier to paint on, since most of the triangles are, or most of the polygons are taken into account for that population, kind of stored in an internal cache of carbon scatter, and does take a lot longer to populate and paint. So now we can also go a few steps further. In this case, we were using the dirt really just to populate the gravel. So remember, we had that mask that we used to cut out the different areas of the population. Well, rather than running a density map, what we can do is clip this object and just cut it down to reduce the polygon count even further to just what we need. So what I want to use for this is I'm going to start with a Vectorizer. Now, the biggest problem we're going to have with the Vectorizer is that it is going to conform to the ends of the object only. And you'll see what I'm talking about in just a second. So here's my mask. I'm just going to drag it and drop it into the texture area. And that did bring it to the picture viewer because I just quite missed the texture. But basically, once I bake this object, the scale of it is going to be equal to the ends or the spline that's created rather than the original source image scale. So I could go into the image itself, modify it, and add just a few pixels on the corners to adjust that size so that I can match it to the plane. But because I do also have another image which does extend to the end, which is the grass area, what I can do is, instead of using this object first, is replace it with that other one, which has the full extent. And then I'm going to actually copy and paste, and bring in the other one. And you can see that the scale still doesn't match between the two, so we can't really lock them directly, but we can use the other one as a reference. So what I'm going to do is just take a look at the geometry that's being created and make sure that it's going to be detailed enough. We can also scale it to match the edges of the other object if you want to make the original one a little higher res to match it up a little bit better. That can definitely help. And then we can improve the quality and the tolerance. Basically just setting a lower tolerance amount, and it's going to create more points overall, but the polygon count in the end is going to end up being better. So now that these are basically ready to go, we can just hit C on the keyboard or use the make editable command. And then we can scale those up to match the other object. Now, because I have them joined together, we don't really have an actual amount to use. So we'll just eyeball it instead of keying in a number. And you just zoom into one corner, and since it's scaling from the center, you should be able to just get it lined up. So now what we can do is just perform a Boolean operation, which we're going to need to extrude these first. And then we can create multiple objects, one for each area, if we wanted to also populate the grass onto this new lower res object, or paint on it, or whatever you want to do with it. Because this is more restricted, with the cutout, it'll probably be easier for a population. But what we want to add in is an Extrude Nurbs object. And we're going to create two of those, setting the extrusion on the Y to 1. And we'll go ahead and do that for both of these splines. And we just turn this other one off for now, and we're going to use this Extrude Nurbs to make sure that the caps are connected. We're going to add a connect object, add that to the connect object, and then we're going to add in a Boolean or a Boolean object, and then take the connect and just make sure that it is going to go through the object itself and through that dirt object. What we can then do is just cut it out. I'm going to set up, and it's a good idea to set this up first, especially when you have higher geometry, because the calculations can sometimes take a long time to perform, and you don't want to have to wait switching between different things. So it's a good idea to kind of set this up first. So what we're going to do is A without B. Or, sorry, actually, we'll do A intersect B. So we should have dirt as A and connect as B. And there we have our cutout. So we could just use current state to object. One thing, especially with where the posts are, making sure those stay square, you will want to make sure that if you decide to run another polygon reduction on this, that you make sure that the boundary curve preservation is turned on in order to make sure that those stay square and don't get cut out too much. So we can do this with both objects and now have a nice low res object to populate on, and that's going to work out much faster. There are a lot of polygons that are extra that are probably going to need to be cleaned up, or we can play around with the settings a little bit more, but mostly running a polygon reduction afterwards will take care of most of that, but still look pretty good. I chose to do the polygon reduction first before the Boolean just because it'll take a lot longer to cut out the object from a high-res object. So even if you have to run it twice, it's still going to end up turning out really close to the high-res geometry, at least enough, where if you need to get really close and control objects correctly, have more definition than just a plane, this works pretty well.